Tectonic plates are large, irregularly shaped slabs of solid rock that glide over the Earth's mantle. They form the foundation for every geographical feature, from mountains to deep ocean trenches. These plates are also responsible for various natural phenomena, including earthquakes and volcanoes. To better understand tectonic plates, let's quickly review the structure of the Earth. At the innermost level lies the superheated core, followed by the mantle, which makes up most of the Earth's interior and consists of rocky material. The outermost solid layer of the Earth is known as the lithosphere, which includes the upper mantle and the crust. This layer ranges in thickness from 36 to 87 miles. On this layer rest the massive, variably shaped slabs of solid rock that we call tectonic plates. The size of tectonic plates is not uniform. It can vary from a few hundred kilometers to thousands of kilometers across. The Antarctic and Pacific plates are the largest tectonic plates. This irregularity also applies to their thickness. Some plates can be as thin as 15 kilometers, while some of the oldest ones can exceed 200 kilometers in depth. The Earth's crust consists of 15 to 20 tectonic plates, which are constantly moving. Sometimes they move towards each other, sometimes away from one another, and at other times they slide past each other. This movement is known as plate motion or tectonic shifting, and it's responsible for causing earthquakes and volcanic activity. However, Earth's crust was not always structured this way. More than 250 million years ago, there was only one supercontinent called Pangaea, and a single ocean known as Pangaea. Over the years, as the Earth's mantle heated and cooled, the outer crust developed cracks. Through these cracks, the original giant plate fragmented into smaller plates, which have continued to move and evolve to this day. According to the National Ocean Service, Earth's land masses move toward and away from each other at an average rate of about 1.5 centimeters per year. To put this in perspective, this rate is roughly equivalent to the rate at which our toenails grow. However, this movement is not uniform across all land masses. For example, coastal California moves almost 2 inches each year, whereas the interior of the continental United States is more stable and moves comparatively slowly. So, how do these massive tectonic plates, which can be hundreds of kilometers across and weigh billions of tons, move? Their motion is driven by their position, sitting on a semi-molten layer of Earth's mantle. The Earth's internal heat creates slow convection currents, causing the hot material near the core to rise, while relatively colder mantle rock sinks. This process is somewhat similar to how water boils in a pot. Hot water rises, while colder water sinks to the bottom. Since these tectonic plates are constantly moving, they collide, pull apart, or slide next to one another. The locations where segments of these plates meet and interact are known as plate boundaries. There are 3 main types of plate boundaries. Tectonic plates move away from each other at what are known as divergent boundaries, or spreading centers. Due to divergent boundaries, we have mid-ocean ridges, which are basically mountains underwater. Next up are convergent boundaries. As the name suggests, plates move towards each other at convergent boundaries. These boundaries are the reason we have mountain ranges like the Himalayas and the Alps. Then there are transform boundaries, where tectonic plates slide past each other. These can cause earthquakes. The concept of Earth's continents drifting over time was first proposed by Alfred Wegener in 1912. However, the theory of plate tectonics was only fully developed and understood from the 1950s onwards. Tectonic plates play a crucial role in our planet's geology. They are responsible for the formation of stunning mountain ranges, as well as phenomena such as volcanoes and earthquakes. It's remarkable to consider that these powerful forces of nature are constantly at work, reshaping our world right now, right beneath our feet.